Good afternoon, ladies and gentlemen. My name is Elias Grampas, and on behalf of the European Parliament Intergroup on Climate Change, Biodiversity and Sustainable Development, it's with great pleasure to welcome you to today's webinar, where we'll be addressing forecasting fish distribution and abundance in the Atlantic Ocean, and specifically the challenge of balancing exploitation and sustainability. Before we kick off, I would like to take the opportunity to thank MEPs, Ms. Carvalhais and Mr. Karleskind for taking the lead with regards to hosting today's webinar, as well as colleagues from Blue Action, Mission Atlantic, and Triatlas projects for kindly co-organizing this event with us today. Prior to passing the floor, I would like to invite our audience to send us your questions via the Q&A box of the platform. You can do that during the event, choosing the All Panelists option. When you do that, please also make sure to indicate the speaker to whom your question is best addressed, so that we can facilitate a fruitful discussion to follow. So once again, thank you very much for joining us today. Without further ado, Ms. Carvalhais, you have the floor. Thank you very much.
Hello, thank you, Elias, and good afternoon, everyone. I would like to start by welcoming the speakers, the representatives of different stakeholders, and my fellow colleagues, members of the European Parliament, who will be participating in this afternoon's debate. I wish also to welcome and to thank everyone who follows this online event, as we all know that current circumstances do not allow us to be gathered in the same physical space. But fortunately, we have technology that allows us to continue to have these meetings and to discuss such important subjects. And today I want also to thank the European Parliament Intergroup on Climate Change, Biodiversity and Sustainable Development for all the work and organization of this event. As always, exemplary organized, extremely good on important issues at the right time as well. In the next 2 hours, we will get to know a little bit better 3 projects that have been financed by European funds that work towards a common goal to forecast the future of the climate, the environment, and the marine resources in the Atlantic. We are going to listen about the projects Blue Action, Arctic Impact on Weather and Climate, which started in 2016 and will end next year. The Triatlas, Tropical and South Atlantic Climate-Based Marine Ecosystem Predictions for Sustainable Management, which runs from 2019 until 2023, and also Mission Atlantic, towards the sustainable development of the Atlantic Ocean, mapping and assessing the present and future status of Atlantic marine ecosystems under the influence of climate change and exploitation, which started this year and will have a duration of 5 years. Obviously, no one better than those involved in the projects to talk about their objectives, the work already developed and results, whether already obtained or expected. I think I can dare to say that each one looks very, very interesting and quite ambitious. I will intervene again in the reaction phase to the presentations. And for that reason, I will not dwell now on the opening words. Anyway, I would like very much to convey some ideas about my view on the importance of scientific knowledge in supporting technical as well as political decisions for the correct and sustainable management of both the environment and the economic activities, particularly those more dependent on wild living resources such as fishing. In a direct and indirect way as well, everybody, citizens, organizations, enterprises, we all look, for instance, at the weather forecast to manage our daily life, whether to take relatively simple decisions, such as planning a weekend, should we go to the beach or not, or to make much more serious decisions regarding economic activities, such as planning when to perform a particular outdoors operation, or when should the fishing vessel go to the sea. Of course, when planning a leisure period, the predictions will help choosing perhaps the necessary protection clothing or equipments. But when it comes to exploring resources and maintaining their future sustainability, the question is much more complex and relevant. I argue, as most of my fellow colleagues, members of the European Parliament, that the resource management decisions should always be based on the best available scientific knowledge. And for that, data is essential. In the Fisheries Committee, just about 2 hours ago or something, we were discussing this morning the report on the implementation and functioning of the Union framework for the collection, management, and use of data in the fisheries sector, and support for scientific advice regarding the common fisheries policy. Although it is always possible to do better, it seems that at this point, member states in general have taken important steps in the collection of data and have been working positively to contribute to a better understanding of the fishing activity that is carried out across the European Union. And that, again, I say is very important for scientific knowledge, but for this knowledge to be used to support political decisions, as well as the management of the environment, of resources, and of the exploitation activities, it is necessary to make predictions and to be able to simulate scenarios. Predicting what happens with the ecosystems is essential to assure the sustainability of natural resources, but also of fishing activity. The need to make predictions is increasingly complex, as we know, and increasingly important, especially in a historic context when climate change is so acute that we cannot ignore it. To predict what it happens and what will happen in the future, taking into account the behavior of various changing variables is, I would say, vital. Forecasts in general always have an associated error and some degree of uncertainty, as we know. But when we talk about forecasts in which a large part of the variables are not controlled, these uncertainties are much bigger, and decisions become basically, I would say, acts of random mixture between intuitions and empiricism. And oceans, I would like also to say, are a very dynamic and complex environment, as we know. And when we add the impacts that climate change is bringing into this system, it makes the management of living resources even more complex, as well as essential for the future activity of fishing companies, communities. If on one hand, we must guarantee the protection and sustainability of the environment, we also must work for the sustainability of economic activities that, as we know, depend on the exploration of wild fish resources. And I think that the balance or a balanced interconnection between these pillars, environment and economy, they cannot be dissociated because ultimately they affect the survival of many fishing communities, but also the survival of the oceans, and therefore our own survival as a species. To finalize, we must ensure that we still can reverse the negative impacts that our actions have been causing on the environment, but also that we can continue to explore somehow the marine resources, but in a much more sustainable manner, contributing with a healthy fish, healthy fishing products to feed populations. And science is very, very important to solve this difficult equation. So I will finish here my initial words. I hope to come back to you to the discussion that we will have after our 3 presentations. Thank you very much, and I hope you will all enjoy this excellent event. Elias, back to you.
Thank you very much, Ms. Carvalhais, for setting the scene with regards to today's discussions, underlining the timely nature of the event, but also highlighting the importance of the science policy nexus, which has been a cornerstone within the mission of the intergroup since its establishment in 1994. Next on, we have Mr. Zamboukas, working as a policy officer in the European Commission, DG Research and Innovation, where he develops research policy underpinning the common fisheries policy, but also the Blue Growth Agenda. Prior to joining DG Research, Mr. Zamboukas also worked in JRC, which stands for the Joint Research Center of the European Commission, providing scientific and technical support for the implementation of MSFD, so the Marine Strategy Framework Directive. So I think an intervention we're all very much looking forward. Mr. Zamboukas, you have the floor. Mr. Zamboukas, I'm very sorry. It looks like your microphone is muted. We cannot hear you.
Hello? Is it okay now?
Yes, we can hear you perfect. Thank you very much.
Thank you, Elias, and apologies for this technical problem. Dear honorable members of the European Parliament, Mrs. Carvalhais and Mr. Karleskind, thank you for hosting this event and for giving us the opportunity to make remarks. I will take this opportunity to talk about, to give a short overview of the research on fisheries that the EU is funding. Can you see the presentation, please?
No, we cannot see that.
Maybe,
right.
Maybe, I'm sorry, that's, so share again, okay. I hope now it's okay.
Okay, this is perfect. Thank you very much.
In the Healthy Seas and Ocean Unit of the Healthy Planet Directorate, we support with research and innovation the Common Fisheries Policy and the Blue Growth Agenda. And this is done, of course, through the multi-annual framework programs. The current one that is finishing now is Horizon 2020. And this is what we funded in the beginning of Horizon 2020. We focused on the discard ban, on the elimination of discards in European fisheries, as this was a novelty of the reformed Common Fisheries Policy. And Project Discardless and me now worked on how to avoid unwanted catches and how to handle unavoidable catches with case studies all over Europe and, of course, in the Atlantic. Then we funded two projects on a very hot topic, literally and metaphorically, the effects of climate change on fisheries and aquaculture, and two big projects, Climefish and Ceres, worked extensively on this, using the available data, developing models, testing scenarios, and highlighting both threats from the shifting fish stocks, but also opportunities resulting from these shifts, and also new opportunities for aquaculture industry in Europe. And the project Blue Action that is running also from Horizon 2020 is taking stock of these developments, particularly in the Ceres project, with which there are common partners, and making forecasts for fish distribution. And together with the Tree Atlas project and the Mission Atlantic project that organizing today this event, are contributing very directly to the Atlantic Ocean Research Alliance. That is an effort to coordinate research investment across the Atlantic, and two milestones in this process are the Galway Declaration for the North Atlantic and the Belém Declaration for the South and Tropical Atlantic. And all the projects that I'm presenting today very clearly contribute to the Atlantic Ocean Research Alliance with very concrete case studies, such as the two projects on new technologies in fisheries, the SmartFish and the Symbiosis project, that try to show us how to incorporate new technologies in the fisheries sector, particularly also in the data collection in the monitoring sector, such as machine learning, artificial intelligence, acoustics, and other, to make monitoring of fisheries less destructive and less costly. The Symbiosis project is particularly developing an underwater optoacoustic system to have real-time information on fish stocks, on their abundance, composition, on the shift, and also on the condition of the marine habitats. Another project with a very strong Atlantic component is the Farfish project that tries to increase the scarce data, information, knowledge about biology, ecology, about tools to manage fish stocks outside the EU, but in areas where the EU fishing vessels fish, such as the high seas in the middle of the South Atlantic, or the waters of Mauritania, Cape Verde, Senegal, where the EU has established sustainable fisheries partnership agreements. Another project, Pandora, is trying to fill gaps in knowledge that really exist in stocks that we thought were well studied, but still major knowledge gap exists in the European seas, including, of course, the Atlantic Sea, focusing in the Atlantic in two very sensitive economically and ecologically areas, the North Sea and the Bay of Biscay. Towards the end of Horizon 2020, we focused on the twilight zone, the water column between 200 meters and 1,000 meters, where there are indications that in this mesopelagic zone, there is a massive biomass, but we know little of what this biomass consists of, which species, how they interact, and meso and summer projects are trying to give us an idea of what lives there and who it's who and how much there is, and if there are possibilities for sustainable exploitation of the biomass for food, feed, pharmaceuticals, nutraceuticals, and other. And of course, this is very relevant for the Atlantic Ocean with its mesopelagic unknown zone. Finally, we thought that the last topic in Horizon 2020 will be the topic trying to put fisheries in the full ecosystem context, working on the all-encompassing concept of ecosystem-based approach to fisheries management. And a topic on this is in the last year, and projects proposals are now under selection, and soon there will be the results of the selection. And we hope that this project will tell us more operationally how to apply the ecosystem-based approach, also in the Atlantic, also to support the Atlantic Ocean Research Alliance, and to support the Common Fisheries Policy, but other policies also, such as the Blue Growth Agenda, the Marine Strategy Framework Directive, the Maritime Spatial Planning, and several of the Sustainable Development Goals of the UN. Luckily, at the end of Horizon 2020, there is an additional call, the Green Deal call, that is developed to underpin and support the Green Deal of the Commission, that the Green Deal, of course, is aiming to make the EU a climate-neutral planet and has a continent and has several strategies. The most relevant for fisheries might be the farm-to-fork strategy, and there is a dedicated topic on this, where researchers are encouraged to apply a food systems approach that include, of course, seafood in this. But here I will focus on a completely marine topic, the topic that the Commission is asking consortia to develop a digital twin of the ocean. And this is the digital twin. We see it as a digital representation of the global ocean with all its components, biotic, abiotic, with all information, also social and economic, existing nuance, and to provide a platform where modeling can be done, scenarios can be tested, and of course, forecasting can be done. And this is extremely relevant for the topic we discussed today about forecasting fish population. And it's also relevant for literally all the blue sector economic activities. This is an open topic, and we expect consortia to come up with ideas on how to establish this digital twin of the ocean, and the Commission foresees around 12 million as contribution to this topic. Finally, I will give you some idea of the next program for research and innovation, Horizon Europe. This is its preliminary structure. The budget is not yet decided, but most probably will be substantially higher than Horizon 2020. Most of the fisheries research, the collaborative one, will be under Cluster 6, that includes the whole bioeconomy, the natural resources, and the environment. And under this cluster, a big mission on healthy seas, oceans, coastal and inland waters is being developed. This will be a big investment, including research and innovation, but not only, and hopefully will have tangible impact and already have. And the board, the mission board gave us a first idea of how they see the mission developing, and they see it as a starfish, you see on the right, and on the top top left branch of the starfish, the mission is aiming to fill the knowledge gap and the emotional gap between the citizens and the ocean, because there is the perception that we know little about the ocean and citizens have difficulty relating emotionally with the ocean. And in the recently published report of the committee of the board, the digital twin is mentioned several times as an enabler to bridge this, to fill this gap, this knowledge and emotional gap. And these are the broad lines that the work on seas, ocean and inland waters in Horizon Europe will be around. And you see that it will address technologies for digital ocean, for blue cloud, for monitoring and predicting capacities. And for this, the briefing, the policy brief that we're discussing today is very relevant and very useful. And of course, climate issues and how climate and oceans interact and what can we do to mitigate and adapt will be one of the major broad lines. And by this, I would like to thank you and thank particularly the European Parliament Intergroup on Climate Change, Biodiversity and Sustainable Development for organizing this event and for supporting our work continuously. And of course, our projects, Tree Atlas, Mission Atlantic and Blue Action for organizing this event and for drafting this policy brief. And I'm looking forward to following the next remarks and the discussions. Thank you very much.
Thank you very much, Mr. Zaboukas, for presenting us the excellent work put in place by the European Commission. Also for highlighting the importance of food security, new technologies and innovation when it comes to today's discussion. Also the need for reliable data. So I'm very glad that towards this direction, we have with us Mr. Jörg Schmidt. Mr. Schmidt is chair of the Science Committee of the International Council for the Exploration of the Sea, ICES. Moreover, Mr. Schmidt was a recent co-chair of the ICES Strategic Initiative on the Human Dimension, while currently working on marine socio-ecological systems and concepts of sustainability in the ocean. So in an attempt to sum up his work, we can fairly say that Mr. Schmidt seeks to improve communication between science, policy, stakeholders, and also the general public. So without further ado, Mr. Schmidt, you have the floor.
Thank you very much, Elias, and I hope that you can hear me and see the presentation in full mode. Thank you very much for inviting me to today's event. And hello to the members of Parliament and to all friends and colleagues attending the webinar. It is my pleasure to give this presentation, and just briefly, I very much like the introduction by Isabel Karleskind about the using the best available science or the best available evidence to provide information and advice to policy and decision making. And ICES as an organization is, of course, a lot of the experts that are working in the different EU projects are also contributing to the over 150 expert groups that are working in the wider scientific community in ICES that are providing the science that then can be used to translate that into meaningful and useful advice. But I'm not talking about that today. Rather trying to introduce you to the complexity of the concept of ecosystem-based management. And let's see if I can achieve that. There's many different definitions for the ecosystem-based management, but if we take key phrases, and this is also why ICES is using key phrases that are the central tenet to the ecosystem-based management. What is it all about? It's about management of human activities, of course, and we need to consider collective pressures. We need to achieve a good environmental status or keep a good environmental status. We want to look into benefits or balancing benefits among diverse societal goals. It's about sustainable use. It's probably also about regionalization. I'm coming to that in a moment. It's about looking into trade-offs and understanding trade-offs. And it's about stewardship for future generations. What is the basis for this? The basis is, of course, on looking on the three pillars in quotations of sustainability, and in quotations because it's developed with the idea that you have these different pillars of sustainability, but Daly and Griggs actually coined it much better, I think, with the nature being the basis for society and then economy based in society. So the dependence becomes much clearer. So in essence, an ecosystem-based approach to management means that we need to balance human activities and environmental stewardship in a multiple-use context. So we have the complexity of the climate system, the ocean system, the ecosystems within the ocean, and then all of the human activities. And we're managing the human activities in this complex environment. So how could we disentangle a little bit this complexity? Because we don't want to surrender in light of the complexity. But we want to have a tangible approach to look at it. So one way that ICES is doing that, and ICES is mandated to give advice not only on fishing opportunities, but it's also providing an overview on fisheries in a broader sense through the fisheries overviews, and is giving an overview of the state and the trends in ecosystems in different ecoregions. I took here an example of the Greater North Sea ecoregion, and you can find all of that information on the ICES page, by the way. So this schematic is part of a larger document laying out the state and trends in the ecosystem. But this is key, I think, to understand a little bit that we have several key human activities that are taking place in the Greater North Sea, and they all exert pressures: selective extraction of species, abrasion, substrate loss and smothering, and others. And those pressures are affecting different elements of the environment: habitat, food webs, productivity, and so on and so forth. So we have all these links, and how can we manage that in a meaningful way? And are there boundary conditions? So to illustrate that, I'm running you through a small animation. So let's imagine an ecosystem, a marine ecosystem here with a lot of different species, animals and plants. We have zooplankton, we have fish, we have benthic species, and then we have human activities here depicted as an example through fisheries and maybe an industry that is land-based. What we do need to understand is, of course, the biology and physiology of the living beings in the system. We need to understand the interactions between these different living beings, meaning the ecology of the system. We need to understand the effect of the environment, meaning the abiotic variables like temperature, oxygen, salinity on all these living beings. And then we need to understand how the human activities affect the ecosystem, but also how different activities interact with each other. And all of these we do need to understand in a local regional context to be able to manage that in a meaningful way. But then we have global drivers being population growth, being technological development, and being climate change. These are global drivers that are hardly possible to be managed on a regional or local scale, meaning that they kind of exert boundary conditions that are affecting all of the different activities in terms of population growth. Of course, it changes demand for example, for food, technological advancements, changing the way that these human activities can be put forward, capacity that is increasing, for example, in fisheries, renewable energy production, and others. And then climate change that is, of course, directly affecting all the living beings and the system ocean as such. So for the sake of coming back to the core topic of today's event, I'm focusing on climate change as a key driver. Climate change meaning not only the change in climate, but also the climate variability. We always saw climate variability as kind of an underlying thing that was implicitly always considered in a way. But now we have with climate change an overlying trend that needs to be considered specifically, and that of course challenging. It is increasing temperature, it is changes in oxygen content, it is a change in acidification of the ocean and others. So that means, in light of the ecosystem-based approach to management, that climate change is affecting ecosystems in a way that challenges science and also governance. And the ability to respond to climate variability and change is key for resilient fisheries and dependent communities. So what does it mean in terms of fisheries? So the two key effects that we can maybe observe when we look into climate change on fish stocks is changes in productivity and changes in range, distributional changes. Changes in productivity affecting caps of future yields, and change in range affect where fish are caught and who can catch them. And we'll hear a little bit about that, of course, in the upcoming presentations. So introducing the next presentations will showcase examples where sufficient observational data and system understanding allow the development of models to forecast climate, ocean, and ecosystem components. And it's important to understand that, of course, those are really examples, and they were possible because we had sufficient data, we had sufficient system understanding, and that was the basis for being able to develop the models, which is, of course, in itself a rather complex thing to do, to be able to actually produce these forecasts with all the considerations that also have been mentioned with respect to uncertainties that are attached to these forecasts. So with that, I thank you very much for your attention and looking forward to the rest of the event and, of course, to the upcoming presentation. Thank you very much.
Thank you very much, Mr. Schmidt, for your key remarks, specifically for focusing on the need of resilient and sustainable fisheries, but also on shedding some light on the importance of ensuring livelihoods when it comes to today's discussion. So right next, our following speaker is Ms. Femke de Jong, who is a scientist at the Royal Netherlands Institute for Sea Research with extensive observational and also seagoing experience. Through Blue Action, Ms. de Jong is also a principal investigator in the OSNAP project, which is a transatlantic observational array measuring northward volume, heat, and salt transport. And she also has a Dutch VD project studying the impact of increasing meltwater fluxes on the circulation. Last but not least, Ms. de Jong is also currently a member of the strategic committee for the Dutch Polar Program from 2021 up to 2025. So, Ms. de Jong, the floor is yours. Thank you very much.
Thank you very much. Good afternoon, and thank you all for attending. I would like to take this opportunity to show you some of our observational systems, and mainly their opportunities and their limitations, and then also where we need to go with observations in terms of the European goals for the Green Deal. So the ocean circulation is one of the main drivers behind changes in ocean properties and also in ecosystems. For example, it redistributes heat from the equator to the poles, which is truly important for climate. For us in Europe, the Atlantic Ocean is particularly important for our local climate and also for our fisheries. But the ocean circulation not only connects oceans from north to south and from east to west. Knowledge about the vertical structure and the deep ocean is equally important. I'm trying to show you this by this graph. This is a north-south section through the North Atlantic. where you see warm surface waters moving northward in the upper ocean, where they are transformed to deep water that flows south again. And these vertical exchanges of water, but also of nutrients between the deep ocean and the upper ocean are very important for productivity and ecosystem. However, this circulation and these processes are not fixed. They have their own variability and they are affected by climate change. And this in turn affects our marine ecosystems. So there is variability in time shown in the upper left, for example, by this time series of changes in Atlantic sea surface temperature. And the changes in time are not only climate change trends, but also natural variability on decadal timescales, which make it very difficult to tease apart these systems. There's also variability in space, as you can see in this map of upper ocean heat content, where local changes might not follow the same global trends, but can have a very large local impact. And then there is variability in parameters as well, where, for example, temperature affects fish habitats, but the fish responds to other impacts as well, like fisheries. So even though they are connected, they do not vary identically. So we need to observe both to understand how they are linked.
Mr. Young, this is Elias Grampas. I'm sorry to interrupt. Would it be possible to have your PowerPoint presentation in full screen mode?
I thought it was. Sorry. Can I stop sharing first and try again?
Yep.
Is this better?
Yes, thank you very much. It's perfect.
Okay, now the web window has disappeared. So we have developed a whole spectrum of kind of observations to deal with these different types of variabilities. And these range from ship surveys to automated sensors and floats. And we've come a long way from where we started with thermometers and buckets of water, but we still have a long way to go as well. So as an example of our increasing surface observations, these are temperature observations. These are our most common observations. And this is the progression of time and in depth of the ocean. And you see that temperature observations started to increase in the 1950s, and mostly in the upper ocean, which is easily accessible. But if you look at the deep ocean, our coverage is really very sparse still. And also, if you look at parameters other than temperature, we have far fewer observations. Well, what I would like to show you as an example of how we are making steps forward, if you notice this red block starting in 2003, that is the Argo program, which I will tell you a little bit more about. So the Argo program consists of autonomous floats deployed from ships, and these floats have a lifetime of about 5 years. These floats drift at 1 kilometer depth, and every 10 days they record a profile of temperature and salinity from 2 kilometers depth to the upper ocean. Once they appear at the surface, they transmit their data to shore via satellite. And this is one of the success stories in ocean observations. You can see from this map we have global coverage, except maybe for ice-covered regions in the north and south. And this is because countries are making committed contributions to the program with a number of floats per year. You do have to keep in mind that the coverage is still very wide. For example, one of these dots is the same size as my country, the Netherlands, and in this same country, we would have about 50 weather stations recording atmospheric data continuously. So you have to put that into perspective of one float profile every 10 days. Now these are still the upper ocean only and only temperature and salinity. If we go more to parameters relevant for ecosystems like oxygen, nitrate, pH and chlorophyll, there are far fewer observations. And there's 10 times less floats that record these parameters. So there's definitely steps to make from the physical to the biological. Also, these don't cover the deep structure of the ocean, which we also need to understand. If we look at floats that go to the bottom of the ocean to a maximum of 6 kilometers depth, there's even fewer floats. There are some in the North Atlantic. These are being developed and tested by Ephemer in France. And we expect there to be more in the future, but there's still a far way to go. Now, Argo floats are a great example how you can set up a system, but they can't measure everything. For example, they can't measure fish, and they're even very poorly equipped to measure ocean circulation. We have moored arrays in place in the Atlantic at several latitudes that directly observe the ocean circulation and also continuously with hourly data. And these are crucial for our understanding of the circulation and to validate and improve models. Now, unlike the Argo program, these do not have solid funding, nor is there available data in real time. This is mostly practical limitations. We have to go out to sea every 1.5 to 2 years, recover the data, analyze them, and then we know what changes occurred over the last 2 years. Also, what would be really needed is to expand these measurements of physical properties with more parameters relevant for biology and ecosystems, which could be done with the same instruments and the same ship time to put out these instruments. Now, if you look at fisheries data and stock assessment specifically, that has its own problems. A lot of this data is obtained by industry and they have commercial interest. And unfortunately, the same commercial interests do not encourage data sharing. And we need this data to be open and available for predictions and informed decisions. So there's definitely steps to be made on that front as well. If we are to move forward to a real-time monitoring of physical and ecosystem parameters, then much still needs to happen on the observational front. We need to close these gaps in space, in parameters that are being measured, and in how the data is shared. And then furthermore, these observations need to be easily accessible and integrated for use and modeling and prediction. And for example, the digital twin of the ocean could be a way to do that. And that would make them easily available for policymakers to make informed decisions. But in the end, the observations, predictions, and decisions are locked in a continuous cycle. Once a decision is made, we need to keep monitoring the system to see the effect of the decision, to see whether that is accurate, adequate, and it could lead to a new prediction and possibly a new decision. So we have seen that we can put these systems into place, but they need to be expanded and they need to be better integrated. And with that, I would like to thank you for your attention.
Thank you very much, Mr. Young, for your intervention. Our following speaker is Mr. Mark Payne, researcher and associate professor at DTU Aqua. Mr. Payne is a senior researcher of the Technical University in Denmark, in Copenhagen, also coordinating the elements of the Blue Action project focusing on climate services. Mr. Payne has also developed some of the first marine ecological forecast products and climate services in Europe for use in the sustainable management and exploitation of living marine resources. So throughout his work, Mr. Payne has, last but not least, contributed to the most recent IPCC special report on ocean and cryosphere in a changing climate. So Mr. Payne, it's with great pleasure to have you with us today. Thank you very much.
Thank you, Elias. And thank you all for the invitation and the opportunity to talk and to share my work with you. Dear honourable members and colleagues, I'm going to be talking to you today about the work that we've been doing to develop fish forecasts and climate services in the Atlantic region. And when I say the words fish and forecast together in the same sentence, you probably conjure up an image in your mind, something along the lines of this, of a fishing vessel setting out in very heavy seas. And you're probably sitting there hoping that they've got a good weather forecast behind them to ensure that that is actually a wise and safe decision to make. But this is just an example of one of many different types of decisions that need to be made in the marine sector and in the fisheries sector. And so one way that we can start to think about this is in terms of the timescales of those decisions and on which information is actually required. So we can represent this in a timeline running from days and weeks out here on the left, all the way out to decades and centuries on the right. So the weather forecast that I just alluded to, and we saw the picture of, sitting essentially here. It's on the very short timescales, days and weeks. And at the other end, we've got the questions around resilience and sustainability, which are questions of the decade or to 2050 to 2100 type of timescales. But in between, there's a whole lot of other questions that are equally important to society and for businesses that are dependent on the ocean. These can be questions about how many people should I employ next year? What will the fishing quota be? How do I manage my fish stock sustainably? How do I monitor the fish stock? Where can I fish? Where should I fish? And these all many of these decisions sit on this sort of months to decades timescale. And so if society and businesses take their questions to science, they'll find that science is very good at doing this timescale, the weather timescale on the days and weeks. And we have here an example of a weather forecast for France. And out in the other extreme, we have got to be very good at making climate projections and thinking about these longer term timescales. But the gap still exists in the middle, where the most need for information actually is found. This is also a situation that is changing and changing rapidly. And the reason for that is that we now have the types of observations that Femke has been talking about in her talk. And we can take these observations and couple them up to ocean forecast systems, to climate prediction and projection models, and use them to actually make forecasts of the ocean itself, temperature and salinity. But that's still not enough to actually answer the information needs of society. We actually need to go further and think about turning these into forecasts of things that are society relevant and that people can make decisions based on. In other words, we need to take the data on the left-hand side and convert it to information on the right-hand side. And to give you some examples of how we've been doing this and how we can do this, I'm going to give you two examples here today. The first of these is for a species called blue whiting. This is a fairly small, it's about that size, mesopelagic fish that's found between 300 to 600 meters depth out in the open North Atlantic Ocean. You may not be familiar with this, but it actually supports an extremely large fishery that's very commercially important for communities such as the Faroe Islands and many of the coastal communities in Europe. And in fact, in the early 2000s, it was one of the world's largest fisheries, buried substantially over time. One of the challenges that is present in this particular fish stock is its variability, and the variability in where it's found. To illustrate this, I have a picture here from 2007, and this is data from a scientific monitoring survey where you can see where they observed the particular fish. And that's the picture in 2007, and this is the corresponding picture, exactly the same data in 2013. And straight away you can see that there are substantial differences in where you find the fish. The left-hand side we see a very expanded distribution, right-hand side it's much more compacted on the continental shelf edge. So we've been able to investigate the processes that control this and determine this. We find that the left is associated with warmer and saline oceanographic conditions, while the right is associated with colder, fresher conditions. And the point where this actually becomes important becomes very apparent when you superimpose on top of this the exclusive economic zones in this particular region, and particularly how they will look most likely under once the United Kingdom leaves the European Union. And you can see here the area that I've highlighted. There's essentially the fish distribution is moving in and out of various countries' regions, sometimes in international waters, sometimes primarily in the UK waters. And there's a substantial degree of variability across national jurisdictions. And it's exactly this type of variability that we've also seen further north in the North Atlantic that's led to the well-known conflict over mackerel, for example. So based on this knowledge that I've just described to you and the links to the oceanographic conditions, we can actually take this further and start to think about forecasting this variability. And that's exactly what we've done. What I have here is an example of our distribution forecast that we issued in January 2018. The colours correspond to where we expected to see suitable habitat for the species. And then that was issued in January. And then in March 2018, the scientists went out and measured where they found fish. And this is what you see superimposed on the top here, with the crosses where there weren't any fish and the points where there were fish. And we can see that there's really quite a good match. The very compacted distribution that we forecast in January turned out to be held up when we went out and actually observed them in March and April, 3 months later. So if you think about that in terms of a weather forecast, that's actually already much longer timescales than your typical weather forecast. And this is being used, we're still issuing and generating this forecast every year. And this is being used in the planning, particularly of the scientific monitoring of the fish stock, but also in the fishery itself as well. The second example I have for you is of bluefin tuna in Greenlandic waters. And your first reaction to that is tuna in Greenlandic waters? That doesn't quite fit together. And that's correct, that's because tuna are normally found in much, much warmer waters than those around Greenland. However, in August 2012, and then again in 2014, there were actually catches of bluefin tuna in this particular region. I've put it on a map here, and you can see it's in the area between Greenland and Iceland, in the Denmark Strait region. And so we went back through this when we heard these reports and found these very unusual observations. We went back through the literature and the history books, and as far as we can tell, this is the first report of tuna in this area for at least 370 years, and probably the first report or documented report by humans ever. And so we actually have been able to link this up to the oceanographic conditions and to the warming, particularly that has taken place in this region in recent years. And so based on that, we can actually start to think about forecasting. And this is what we've done here. This is our bluefin tuna habitat forecast. And in this particular case, we issued the forecast in September 2018. And the forecast was for the following August. So that's actually full year ahead forecast that we've been making here, where the colours correspond to the likelihood of that particular region being suitable habitat. And the lines are essentially our demarcation of where we think the boundary for the habitat actually exists. And so it doesn't actually stop here at 1 year ahead. And we can actually go in and do the scientific assessment that shows that these forecasts can be made reliably up to nearly 10 years into the future. So the unusual observations that we have seen that I just talked about in this Denmark Strait region, we've shown, for example, that they could have been foreseen more than 5 years in advance. So these are some examples that I've given you quickly of some proof of concepts to illustrate that we can actually start to think about making these forecasts and that they do have useful applications. So how do we go forward with this? There are 3 ideas that I think we should bear in mind and that are particularly useful. First is we need to really think about co-design. We need a close collaboration between the users of the forecast and the producers to ensure that they're actually useful and meet the needs of society. Secondly, we need to think about scaling up and operationalization of these forecasts to expand them not just from the few fish stocks that we've done so far, in fact, across as many fish stocks in Europe as we potentially can, and hopefully also to the global south, where the ocean dependency is much, much higher than that we see in Europe. And thirdly, we also need to think about this as an adaptation tool. The most recent IPCC report highlighted the potential of fish forecasts in supporting adaptation of ocean-dependent communities to a variable and changing climate. And so we need to make sure that these tools are actually taken into account and used to their full potential in a climate adaptation context. So if I sum up quickly, I hope I've convinced you in this short talk that we can actually predict biological variability in the ocean and that we have proof of concepts and we're now ready to scale this up, to spread the tools out and to operationalize these forecasts. But when we do that, we need to be guided by the needs of society, ensure that the forecasts that we develop are useful and that they ultimately support balancing the exploitation and sustainability in the ocean. If you're interested in seeing more examples, our website is fishforecasts.dtu.dk. Otherwise, I thank you for your attention and hand the baton back to Elias. Thank you.
Thank you very much, Mark, for your remarks. It looks like we have in place all data translated into key information towards well-informed science-based policymaking. So on this note, it's with great pleasure to invite to the floor Ms. Laura Meller, who is an ocean policy advisor with Greenpeace Nordic, also co-leading the global Greenpeace campaign Protect Our Oceans. Before joining Greenpeace, Ms. Meller also completed doctoral studies at the University of Helsinki, studying EU policy responses to climate change with regards to biodiversity conservation, as well as protected area networks within the EU research project entitled Responses. Last but not least, Ms. Meller is also an advisor to the Blue Action Project on societal engagement. So Ms. Meller, thank you very much for joining us today.
Good afternoon, and thank you for the opportunity to share some reflections on this very important topic. Reading the news day after day and reading the thick reports that summarize everything we know about the state of the living planet, it's quite clear that the nature crisis and the climate crisis are not some threats in the distant future, but they are a reality that we are living today. And for example, today, the World Meteorological Organization released their report saying that 80% of marine regions have experienced a heat wave during the past year. And the climate breakdown is a threat multiplier, interacting with overfishing, with habitat destruction, with pollution, etc. And all these things together have really been pushing marine life to the brink of collapse. And the good news is, of course, that there is also a wealth of knowledge on the solutions to these crises and how we might address them. And scientists are also increasingly weighing in on the public and political debates with their perspectives, which is also a very welcome and positive development. And one of the main solutions to help marine life, including fish stocks, to recover, to adapt, and to cope with the pressures, is creating fully or highly protected marine reserves across the oceans. Scientists have been calling for at least 30% of the oceans to be fully protected by 2030. And the recent EU biodiversity strategy has taken on this recommendation, and the political support around the world is snowballing, although there is still a lot of work to do to effectively fully and highly protect also the existing protected areas from industrial and other harmful activities, as currently less than 1% of the European marine protected areas can be considered fully protected. And of course, designing such networks relies on good data and good models. Here is just an example of a study mapping a network of ocean sanctuaries in the international waters. So that's why you don't see the many valuable areas in the coastal regions. Combining different data on species distributions, on habitat types, oceanographic variables, and climatic data. Also socioeconomic things like fishing activity, to find a combination of areas that together capture and represent the diversity of life in the oceans. And bringing this kind of planning to a regional and a local level in a future-proof way is, I think, one area where the novel tools for forecasting fish distributions, for example, can really support decision-making. And then, of course, for science to be able to guide sound decision-making, decisions need to take account of scientific advice, and to a greater degree than they do today. For example, despite the commitment to end overfishing by this year, the fishing quotas allocated by the EU Agrifish Council still exceed scientific advice for almost half of the fish stocks, looking at the Northeast Atlantic, the Baltic Sea, and the Deep Sea. And just to note the percentage in the orange bar, it tells you about the proportion of stocks where allowed catches exceed scientific advice. So it's not by how much. And while the figure changes slightly depending on the area in focus, so it would be a bit lower if you'd look only at the Northeast Atlantic, it would be higher for the Mediterranean Sea. I think the overall story would remain the same. So to summarize, in light of what we know about the state of the oceans, it is clear that the focus needs to shift from exploitation to protection. And novel science, such as the fish forecasting methods, can support designing effective conservation. And of course, good data is really essential for building sound plans. The EU fisheries management and marine policy in more general need to take greater account of scientific advice. And finally, while scientific advances will always be good and always be very helpful and needed, we have ample knowledge to support those decisions that urgently need to be taken today. Thank you.
Thank you very much, Ms. Meller, for your intervention, but also for your policy recommendations at the end of your intervention there. Our next speaker is Dr. Manuel Baranz, who is the director of the Fisheries Division at FAO and responsible for the SOFIA report, so the biennial State of the World Fisheries and Aquaculture report. Previously, Dr. Baranz was also Deputy Chief Executive and Director of Science at the Plymouth Marine Laboratory in the UK, and also Chair of ICES Science Committee. Notably, we had the great pleasure to welcome Dr. Baranz at a previous webinar of the European Parliament Intergroup hosted by Mr. Karleskind, presenting us the organization's new vision for fisheries and aquaculture. So I think it would be of great added value for today's debate to also reflect on lessons learned from that. So on this note, Dr. Baranz, thank you very much for joining us today. You have the floor.
Thank you. Thank you very much, Mr. Karleskind, distinguished members of the European Parliament. It's a pleasure to see you all again today and to speak to you. Let me start by thanking the European Parliament Intergroup on Climate Change, Biodiversity and Sustainable Development, and welcome the speakers who are colleagues of mine who I've worked with in the past and do excellent work. Let me first react to some of the statements that I have heard. As you probably know, my job is primarily to provide the state of fisheries and aquaculture at the global level, regional level, and national level. And I do not recognize a statement such as marine life is on the brink of collapse. That is not true. Fisheries are an important sector. 35%, 34% of fisheries are overfished. That means that 67% are not overfished. There's a fluctuation between those that are overfished and those that are not, partially due to the natural fluctuations of the resources and sometimes because of overactivity. We actually see a very clear dichotomy in the world, and a very worrying one, and that is that in the developing world, we see a deterioration of the sustainability indices, while in the developed world, we see a clear improvement in sustainability, and that in the developed world it applies to Europe, North America, Australia, New Zealand, where there are very clear indications that stocks are increasingly sustainable and recovering. Colleagues, let me just say, first of all, that the dichotomy nature-humans is no longer defensible. We are not separate from nature. We are part of nature. We do not fix the problems of nature by staying away from it, but by managing our interactions with it, recognizing the facts and recognizing what's going on. Remember, everybody, without nature, there's no food. And as of today, we have 690 million people in the world that are hungry. And today, the World Food Price Index has rose to a 6-year high as a result of the COVID-19 pandemic. If we do not eliminate hunger and poverty, all other aspirations will remain aspirational. And the ocean is seen as part of the solution. In fact, many bodies, including the European Union, have expressed the need for more food to be produced from oceans and seas, and effective management is the only solution to that. Now, the high-level panel for the sustainable ocean economies, led by the Prime Minister of Norway, released a statement yesterday where the countries of the panel agreed to manage 100% of the waters under their jurisdiction. This, to me, is a great success, is what we've been calling for, 100% managed seascapes and oceans. That is because setting conservation targets without paying attention to the rest is not only abdicating responsibility, it is actually setting those targets to fail. Managing 100% of seascapes means using evidence, using science to analyze trade-offs and balance objectives. Management is actually the only possible available conservation to us. Marine protected areas, while necessary and useful, are largely helpless in front of climate change. They are static units that do not act dynamically to the changes that we observe in the climate. Now, let me just first analyze for a moment that in the IPCC, in the International Panel for Climate Change, we distinguish between a prediction and a projection. And what we heard today is a lot of forecasting. Forecasting is actually to predict the future, in the sense that you mean that unconditionally something will happen with some probability. In marine science, we often refer to projections rather than predictions, because a projection is contingent to a number of scenarios, a number of conditions and assumptions. And in the projection of the marine environment, we still have an enormous number of question marks, as my scientific colleagues know. Now, what in FAO we have actually been calling for is to ensure that in climate change, in relation to climate change, that we mainstream climate change in the work that we do. Recognizing that change will happen, that preparation is essential, that maladaptation is something to be avoided, and that adaptation is an iterative process. And what is needed, in our view, is 3 things, is to start working first on very clear institutional and management adaptations to climate change. And those are, for example, through empowering bilateral, regional, and multilateral management systems, especially the regional fisheries management organizations that have a significant contribution to make in managing resources that are changing their distribution and are changing their productivity. Second is part of the first one is to establish management systems that are based on risk management and are robust to uncertainties. There are a lot of uncertainties in relation to the projections of biological production in the ocean. We need to make sure that we build our management on systems that are robust to some of those uncertainties, and there are quite a few of those already available, particularly applied in regional fisheries management organizations. And second, we need to ensure that we adapt livelihoods, and that means providing alternative employment to people that depend from the oceans, ensuring they have access to underutilized resources when they use resources, move, change distribution or change productivity, and promote value chain development to add value to the product and ensure that those that depend on fisheries and aquaculture increase also their incomes. And finally, risk management, and that includes early warning systems, such as the ones that Mr. Young presented today. Ladies and gentlemen, just to finish off, in the FAO, we are calling for something that we name blue transformation. A blue transformation that includes a sustainable intensification of aquaculture, a transformation of the fisheries management in places where management is failing, and we know where it is failing, an upgrading of the fish value chains, and an enhancement of the role of fish and fish products in food and nutrition strategies. colleagues, my job is to make hope possible rather than despair convincing. There are many solutions in the world. We are getting there. There's much work to be done, and climate change is something that we need to face on and mainstream it in our activity on a daily basis. Thank you very much.
Thank you very much, Dr. Baranj, for your remarks. At this stage, I would like to remind our audience to please send us your questions via the Q&A box of the platform, indicating the option for the questions to be sent to all panelists, so that we can then manage the questions received. Our next speaker is Mr. Daniel Vosses, who is the Managing Director at Europes since 2016, having over 9 years of experience in European affairs, particularly on fisheries and maritime policies. Mr. Vosses first joined the organization as policy advisor back in 2012, before which he worked as a consultant in the fisheries sector at the European Social Partners. Additionally, Mr. Vosses holds a master's degree in law, as well as an MA in European Studies, combined with further postgraduate studies in international maritime transport. So, Mr. Vosses, thank you very much for joining us today.
Thank you very much, Elias. You hear me?
Yes, we can hear you very well.
Yes. All right. Thank you very much, Elias, and thank you to the intergroup for the invite, and also members of the European Parliament, Commission, FAO, and all the stakeholders. Good afternoon to you all, and I think it's very relevant that we can all be here today to discuss a really important topic, which is the climate change and how it's affecting our daily lives and our industry. So first of all, I would like to start by talking about the contribution of the fishing industry to combat climate change. So from our perspective, it's undeniable the benefits of our industry as a food provider, because as an industry, we are harvesting wild caught fish. And that means that we are fishing what many consider as the perfect protein. And we said this because the fish, they live free in the ocean, and in order to harvest them, we do not need any artificial fed, water supply, pesticides, or antibiotics. And actually, wild caught fish is also the highest animal protein on Earth. And because of these factors, the European fishing industry has a very low carbon footprint. That we can. It is true that the industry has an impact on the abundance of stocks, but also it's true that no marine fish has ever gone extinct due to commercial fishing. And we also committed to fight climate change. If we look at the figures and data on greenhouse emissions from the fishing industry, we see a decrease of 4% if compared to levels from 1990. And also fuel consumption, of course, is being reduced over the years. It is also undeniable the many efforts made by the fishing industry, and thanks to the fisheries management in the European Union, that we have more and more sustainable stocks and more resilient stocks to face the consequences of climate change. If we look at the numbers from the STCF report and from the European Commission, we see that over the past 2 decades, we have reduced our fishing pressure by 50% in the Northeast Atlantic, which of course as a consequence is more fish. We have 50% more fish in the sea than in 2010. Almost 100% from EU managed stocks comes from MSY stocks, so they are sustainably fished. It was also referred to the Sofia report 2020, where around 78% of the fish that is landed worldwide is sustainable. So we see a balance between biodiversity and food security. So that's why we also agree with FAO that we need to bet and continue pushing for fisheries management, 100% fisheries management all over the world, because it's working and because fish stocks are reacting accordingly. And we do not need any arbitrary targets or reinventing the wheel with new measures that member states are really struggling to put at work. Also, we do believe that the current system that we have in the European Union, the MSY policy based on effort, meaning FSY, is working, and we shouldn't explore any other shift to any other management systems like BMSY or economic MSY or MEY, because from our point of view, they are not operative for the management in the European Union. Despite the good news and the good progress, we see that climate change is a serious problem for fisheries now and in the future. So, of course, something needs to be done. It was already referred by the representative of ICES that we need to consider collective pressures, and exactly we need to do that in the European Union. We have new players in the marine space, like, for instance, renewable energy, and of course they are going to have an impact, and we need to consider this impact in a collective way, checking the cumulative pressures in the ocean. And of course, it's going to be an increased competition over the marine space, and it is essential that our fishermen can still get access to the traditional fishing grounds. It is also fundamental for our companies to have reliable fish forecasts, not only in terms of opportunities, because I'm pretty sure that new target species will arise in our waters, but also because of the declining species, that they will move somewhere else. And of course, for this research to happen, we need adequate funding from the European Union and other institutions. And obviously, we need to use this science to mitigate uncertainty and any potential conflicts. Of course, we cannot be naive, and the conflicts are already happening because fish, they don't know anything about boundaries or EEZs, etc. But of course, we can use science to preempt or to adapt our business models to what is going to happen in the future, and also for member states to take the best decisions based on the best available scientific advice. Also, we need a system that allows us to have and to take really quick management decisions. And also in the European context, I believe that we need to have a deep look into our, for instance, the landing obligation, where that is a policy that with the movement of fish stocks towards the north of the pole, and I'm talking, for instance, about hake or bluefin tuna that was described by one of the previous speakers, is moving north, and is going to create many problems that is going to be aggravated with the implementation of the landing obligation. So for that reason, this should be taken into consideration for future revision. And finally, we still need to, and we are committed to decarbonize the fishing industry by installing new engines, for instance, hydrogen or gas engines. But for that to happen in the European Union, we need to revise the capacity measurements of the fishing fleets from European institutions to replace these all polluting engines from all vessels, large and small. And with that, much, and happy to take any questions.
Thank you very much, Mr. Voces, for your remarks, specifically for highlighting the role of science, sustainability and livelihoods, but also system transformation, as well as for presenting us some best practices and initiatives from your side regarding the decarbonization of the fishing industry. At this stage, I would like to invite our two MEPs, Ms. Karleskind and Ms. Grace O'Sullivan, to react to the previous interventions before we can proceed with the Q&A session to follow. Thank you very much.
Should I start, Elias? Yes?
Yes, please feel free.
Okay, thank you. Thank you very much. This has been a really wonderful afternoon. I've been listening very carefully and your wonderful presentations. We began with Mr. Zampoukas with a rather comprehensive overview of the most relevant projects under Horizon 2020. And I think that we must all acknowledge the most relevant role of the European Commission in financing research and innovation projects that truly help us all to know much more about what is happening in the seas, that help us to find out the methods for a better data collection, better data treatment, to develop and perfect equipment, to take the best of artificial intelligence. So this was really important to hear. Not that we don't know, but it's always important to make sure that we all hear this. We all see that this is deeply intertwined, I would say, with the Green Deal and with its two main strategies. Now I'm working specifically on the opinion, the agricultural opinion for the biodiversity strategy, but I've been following both of them, and both have the goal, as we know, of developing sustainable green and blue economies, based also on what we can call an integrated approach to the food chain. And I would also like to stress the relevance, the importance of a systemic approach, when nature is seen, as Schmidt was saying, where nature is seen as the basis of society and economy and not the other way around, and where we must identify the interconnections between our activities, the impacts or reactions of the ecosystems, and then the results of such impacts. I think we all agree that universal law of physics, action that leads to reaction, is poignantly obvious. And it is up to us to set in practice the actions that may bring new reactions in the ecosystems. As here explained also, and very well by Professor Payne, science is what helps us to forecast, to predict, to setting out the most reasonable scenarios to plan our actions. We need very much some sort of control over what we do. And the more data and qualified data we have, the better mathematical models will get, and then the more reliable the forecasts will be. I think that this all reinforces the need to have more scientific evidence and the relevance as well of the Green Deal as a collective political response that we should take very seriously, a response to what is happening. Because if we look at the Green Deal starts precisely by acknowledging the scientific evidence of climate changes. Of course, the further political, the next political decisions should be aligned with the rationale of the Green Deal. But I would also say never losing sight of the three-pillar approach, where economy is not the center, but must be there. It must be present. It cannot be taken aside. I think that we are in the right track, I would say, to have extensive and rigorous scientific data to help us out with the impact assessments on the side of marine ecosystems. But I would dare to say, I hope this will not be misunderstood. I think that on the side of the economic activities, of what economic actors think, I think they still need to see more sound evidence on the gains that will obtain from more sustainable activities. We also have to take this in mind. I think this would ease their adaptation and have less, how can I say, less negative reactions if they also could see more evidence of the gains they will get. We have been talking about forecasts and scenarios, so we are not simply dealing with a one truth scenario, and therefore we must also work on various economic scenarios that reflect the different risk managements. As an academic, I think science is really, really very important, and that science should never be subjected to ideological appropriations. Science is here to help us find effective, sustainable management, environmental and economic sustainable management, and we should not lose this opportunity. Science, to conclude, is always very generous. We just have to know how to look at it and to bring it the best to help us out in the big challenges we have ahead as a society. That's what I would like to say at this stage. Also, as a sum up of all the very, very interesting interventions that have been listening this afternoon. Thank you very much. So back to you, Elias.
Thank you. Thank you very much, Ms. Carvalhais. I think it would be of great interest to also receive the viewpoints of MEP Ms. Grace O'Sullivan. Ms. O'Sullivan is so a member of the European Parliament as well for the group of Greens, EFA, and currently sits on both PESH, but also environment committees. Ms. O'Sullivan has also worked as an ecological educator and activist and spent over than 2 decades with Greenpeace, sailing on such ships as the Rainbow Warrior. Additionally, she previously served for 3 years as a senator in the Irish Upper House of Parliament, where her work focused on oceans governance and marine protection, housing, climate action, and environmental protection. So, Ms. O'Sullivan, it's really with great pleasure to have you with us today. Thank you very much.
Thank you, Elias, for the introduction. And can I say that this webinar is absolutely superb. The presentations have been inspiring and excellent. And I thank the organisers for bringing us all together today around the webinar and from around the world. And Isabel began by speaking about the weather. And anyone who knows Ireland and the Irish will know that we're obsessed with the weather, and knowing the weather forecast is critical to our day-to-day lives. And also it's critical in terms of safe voyages for all of those going to sea. And also we heard from Mark about fish forecasting and the importance of science to give us the information to allow us to predict and project in terms of governance and issues. So I'm speaking to you today from Ireland South, the south coast of Ireland, and I really believe that this conversation on sustainable fisheries management in the Atlantic is really essential, particularly considering the variables in terms of pressures on the ecosystems, the biotic and the abiotic, social and economic. And as Nicholas spoke about, the emotional gap between people and the oceans. And again, it's something as an Irish citizen I can react to because there is a very strange and interesting emotional connection between the Irish people and the sea. And I think it is really important that we understand how the people along the Atlantic fringes connect with the oceans. And it will be great to see the Portuguese taking up the presidency in the council and what they bring to that in January. Ireland has a maritime space that covers 500,000 square kilometres, and especially following Brexit, which is going to happen soon enough, this space could become increasingly busy. So for us as an Atlantic island, and for all the Atlantic fringe nations, it's really important that we understand the waters that surround us. And as Jorn said, that we balance the human activities and environmental stewardship in the protection of the oceans. And climate change and rising sea level, global warming, like they all put pressures on the environment, as we heard in the various presentations. And it does and will require close monitoring in order for us to be able to react. And Femke talked about the ocean circulation, the thermoclines, and I suppose the ocean dynamics. And again, these ocean dynamics within our oceans is critical to us understanding the fish distribution patterns and how things are changing because of the changing variables in the ocean. Laura spoke about the marine protected areas, and again, we welcome the Commission's EU biodiversity strategy, which will help us hopefully to protect the marine environment and protect fisheries and stocks. But these protected areas need to be based on up-to-date science. And the other area that I've always been interested in is the corridors of MPAs that we need in terms of species migration. So it's really important that there's that interlinked interconnectedness between where we place the MPAs. We also heard about marines, we talked about marine spatial planning earlier. I heard reference to that. And again, this is key to how the fisheries government and marine environment is developed and stocks are protected. So, I mean, the subject is fascinating and brilliant, and as an ecologist myself, it's something I wish we had all day to talk about. I'll conclude by saying that too many stocks are currently being exploited higher than the maximum sustainable yield levels, but we must use technology together with responsible governance to allow fish populations in all sea basins to recover and be healthy, to ensure that we have good seafood, as Europesh have indicated, the importance of good seafood, sustained employment for fishers and all those the oceans, and healthy ocean ecosystems that support abundance and prosperity for all. I'm the rapporteur now on the 8th Environment Action Programme, and all of the discussion we've had today I will be bringing to the development in the area of the 8th Environment Action Plan. So I'll be wishing for all your support on that. But great webinar, and thank you all very, very much.
Thank you very much, Ms. Karleskind, as well as Ms. O'Sullivan, for your reactions to what we've heard previously during the course of this webinar. Judging by the questions received by the audience, but also the messages in the chat box, I understand that everyone is now looking forward to the Q&A discussion to follow, which will be moderated by Ms. Sandra Kettelhake. Ms. Kettelhake is a science policy advisor at the German Marine Research Consortium and JPI Oceans. Her current work focuses mostly on ocean observing related topics like science for good environmental status, as well as the implementation of the All-Atlantic Ocean Observing System, while she is also the German G7 national focal point regarding the future of the seas and oceans working group. So, Ms. Kettelhake, you have the floor.
Yeah, thanks, Elias, for the nice introduction, and thanks to our members of the European Parliament and all of our speakers for the really nice presentations and interventions or statements afterwards. I think we've all learned a lot and noticed that this is a pretty nice fitting topic that is really pretty timely as well. And by going back to what our MEPs, so Mrs. Karleskind and Mrs. O'Sullivan just said in their statements, we would like to have a view, how do you see the role for Europe to move this field of ocean observations and predictions forward? So shall it go beyond the typical 5-year program and calls we've seen in the H2020 Horizon Europe? And it might be as well nice to have a view of Mr. Sampukas from the European Commission on this, especially because you all referred to the European Green Deal, the biodiversity strategy. Mrs. O'Sullivan referred as well to the corridors of MPAs. So I would like to hand over back to you. And if you already have as well some questions that you have to our scientists, just feel free to ask them directly. And then we're going to the chat and see what questions our participants have. So Mrs. Karleskind, you might want to address the question first.
Yeah. I'm on again. Okay, thank you. Thank you very much for your question, Sandra. Yes, one thing that I find very important is that we never lose sight from the fact that Europe has been, and European Union has been leading on many regards the world. I mean, we should not be a kind of embarrassed to admit that we are examples in the world of what others are doing in terms of observation, in terms of scientific gathering. And this should all be something we should be proud of and that we should continue. And I think that definitely all decisions must be taken on the basis of the best scientific knowledge, and science evolves. Data may actually change because the more we know about the ground, in this case the seas, the more we actually have to, well, sometimes to reorganize, revalue, reassess our decisions. So it's not something that we can take for granted and say this will be the ultimate decision or the ultimate approach to this reality in the next 5, 10, 15 years. As reality changes and science follows these changes, we must adapt to the circumstances. And for instance, one of the if I may say so, one of the priorities that, for instance, the Portuguese presidents will have definitely from January on is on the guarantee of the sustainability of the resources. So again, science and data are really important because this will be a major goal that, so not to monopolize, maybe we could come back to this if needed, and I will pass the word now for Grace.
Oh, thanks, Isabel. My reaction to the question is really the importance of long-term planning and long-term planning based on the best available science. And because the global dynamics are changing so quickly, obviously we need to resource and invest in really the most up-to-date science, so best technology to give us the best result. And what I have to be honest, I do have a concern, because if you look at the European Green Deal, which is a really good project out to 2050 towards carbon neutrality, but what concerns me is that the current administration has a shorter life frame. So when this administration, under the leadership of President von der Leyen, moves on, then I have a little dilemma. Who's going to take over, and will they progress and proceed even better? So I do have a concern there, and that's why it's really important that we look at Agenda 2030 and the Sustainable Development Goals in terms of longer term guidance, and also the 8th Environment Action Programme, which also pushes out to 2030, because at least these are frameworks that we can set, particularly the 8th Environmental Action Programme, into legislation. So it doesn't matter who sits in the chair, at least we know that the progress will proceed based on the current science. So that's my only concern, is that in terms of our planning and our management, we have to recognise that the people who are in the governance chairs change. And that's why, for me, legally binding commitments are critically important, because we can build on them. But if we don't have something that's legally binding, then we can run into difficult waters, let's say.
Yeah, thanks for your views, Mr. Sullivan and Ms. Cavajais. Mr. Sambucas, you would like to add something to this, because you are part of working at the European Commission and might have some views on the question as well.
Hello, yes, thank you for giving me the floor. I can speak in terms of research and innovation. I think you raised something previously about the marine protected areas, if I'm correct. I'm very concerned also about how these are going to be implemented. And just to remind you that in the past, in the FP7, that was 10 years ago at least, we had a project, MESMA, on how to designate a network of efficient marine protected areas, and a lot of guidance was given, a lot of good publications were out, and they have very tangible case studies in all European seas. And I don't think it's only a matter of research. It's also a matter of implementation that at the end is in the hands of member states, and it would be interesting to see if what this project proposed to member states was taken, and I'm afraid it was not always taken. So the marine, it's good that the Green Deal, it's extremely good that the Green Deal foresees a large part of our ecosystems, including marine ecosystem protected, and we are ready to underpin, invest in science underpinning these MPAs, but we're not there if research results fall into the death valley, what we call, and do not reach policymakers, and they're not implemented. And there is an open call now on supporting the biodiversity strategy, a Green Deal call that of course includes marine biodiversity, and one of the major tools to conserve marine biodiversity is through marine protected areas. So this is what I would like to highlight. And of course, in Horizon Europe, we hear all voices, and there is a possibility to invest also in this kind of conservation research. Thank you.
Yeah, thanks a lot for your remark as well. And yeah, I wondered with, for example, with the Starfish mission on the ocean seas, we might have as well a frame where we are looking a little bit, yeah, on a longer time scale and not just the 5 years. Now, when I'm looking at our chat, there is a question from Kira G that I would like to ask all of our panelists. Views on the contribution of social sciences in implementing sustainable fisheries and more sustainable ocean management generally. Where do you see the greatest research needs, and how can results link to policy? I think this is a question that Jörn could address pretty nicely, or you could start the discussion on this.
Yeah, thank you very much. That is actually a relatively big question, and I can probably talk for the next hour on that. So I try to keep it very short. Key of my presentation was, of course, that I said that we are managing human activities, and that means that we do need to understand the activities, the economic interactions of these activities, but also like all the social interactions of activities, the communities, and in the end, I mean, you're managing people. So you do need to understand the people. So the relevance is, of course, very clear. And having been the chair of the Human Dimension strategic initiative on the human dimension within ICES, of course, we were pushing very strongly in bringing in more social sciences, and I mean really broadly social sciences, you know, adding expertise in economics, adding expertise in anthropology, adding expertise also in, you know, in the humanities, because it's also important to understand the history of the development, the interrelationship between people and the environment, and the people and the activity, to understand the activities. So that is relatively clear. The question where I would see the greatest research needs and the links to the policy, I mean, I'm a little bit cautious here, of course. I know that a lot of the decisions are being made on a national scale, which means that this is, of course, in the remit of the countries to decide how they want to do that. Still, I mean, understanding the trade-offs and balancing the different needs and making these trade-offs more explicit, I think this is something where we have to work much more on, and we have been starting on making all the different level objectives more visible and more explicit as a basis for understanding how the different activities are interacting in respect to the objectives that are behind them. And that I think is a great need, and that of course directly shows the link to the policies. So I would leave it there, and happy to take, of course, more questions when they come. Thanks.
Yeah, thanks, Jörn, for addressing this question. We have another question that would go to Femke. Looking at Argo coverage, there is no data on coastal shelf regions. These regions are where biodiversity is highest and most fishing takes place. This seems problematic for coupled ecosystem physical science applications. The question was stated by Cooper van Franken.
Yes, that is true. So I showed the Argo program mainly as an example of how we are able to run real-time observational data, and these data are also included in models for weather prediction, and it made large increases there in the scale. But they were designed to close the observational gap in the open ocean. They're not designed to monitor the shelves. But these data, these Argo data, have to be integrated with satellite data that observe the surface, with data from ships of opportunity, maybe from fishing ships, and also from coastal systems, to understand how they are all connected and how they vary together and how they are affected by human impact.
Okay, thanks for this, Femke. Mark, would you like to add some comments to this?
Yes, there's also a lot of opportunity for actually furthering and increasing our observation networks even more, using, for example, ships of opportunity and some of the initiatives that have been done to put instrumentation on fishing vessels, for example, and ferry box instrumentations where you have data collection on regularly sailing fishery has been very important, as is some of the initiatives that are going on to actually work together with the fishing industry to collect data as well. So and that's very much from a fish forecasting and sort of management of the ocean's point of view, where we need a lot of information. So there's a lot of potential there to improve our observation networks further still.
Okay, yeah, thanks for this. And you might want to you might want to start the discussion or answering the following question, Fabienne Jacques. Do we have somewhere the list of top priority species of fish on which we should develop modeling or service at first? Only pelagic species also? Anything at coast? I mean, you can start answering the questions, and then I would like to hand it over to Mr. Vosses and Mr. Barange.
Yes, that's essentially something that we need to do, and that needs to be done as the next step. The meteorologists say that a good forecast is one that's used to make decisions. So in order to develop a good forecast, we have to balance what's scientifically feasible on the one hand with what's useful to society on the others. And it's really only where those two match that we can actually start to think about making reliable and valuable forecasts. So getting a good understanding of the needs of society and therefore prioritizing the potential variables that could be predicted is actually absolutely essential. And we talked earlier about the social sciences. I see that, then it's actually having a key role to play in that, and understanding the human systems, and then working together with the marine biologists and the climate scientists to actually find that point where we can have something that's both feasible and useful. Thank you.
Yeah, thanks, Mark. Mr. Vosses.
Yes, thank you for the question. I think that over the years, the fishing industry has been collaborating more and more with scientists. And I think that for the future, we should still progressing on that side. And now integrating new factors like the impacts of climate change, etc. And how do we understand everything that is happening around us? So I think it was greatly explained by Mr. Payne when he said that we need to better collaborate between users and producers of data. So, to better accommodate and to explore the needs of the industry, of policymakers, of member states, etc. Something that should really work on. And secondly, on social policies, of course, everything cannot be just about the environmental impact or environmental concerns. Also, we need to look at society, and in our case, the fishing industry. So we need to look at how policies are affecting not only fish stocks, but also fishermen. And I think, for instance, the European Commission is moving in the right direction, only providing scientific advice, with also already with some social component. But we also see that some scientific studies from STCF providing data on the status of the sector and how it's progressing or moving in terms of societal needs. And I think it is also important to integrate in the end with our fisheries policies. And of course, well, on international level, I'm pretty sure that Mr. Branch will cover that. Thank you.
Thank you. If it is my turn, Sandra.
Oh yeah, for sure.
Thank you. I'd like to just address two things actually. First, on the issue of projections of what particular species to project. It is easier to make projections of pelagic species because they are more mobile, and it is easier from a mathematical point of view to develop algorithms around the preferences, the thermal preferences, and therefore you can connect directly climate change in the ocean to those preferences and project movements. So it is much easier. When it comes to species that have a particular affinity to the bottom and to coastal zones, then it is much more difficult because temperature is not the only reason why they might actually change their habitat. There are particular connections with particular habitats, and therefore movement is perhaps less expected. Productivity will be expected, and that is much more difficult to predict. But this actually brings one important issue, is that one has to think about also what to do once you predict a particular change. What do you do with it? It's not sufficient to say, well, this species might actually move in this direction. What are the consequences for the management of that species? And that's why I said in my intervention that adapting institutions and adapting management systems is absolutely essential before we can actually predict what's going to happen. Otherwise, we're going to find ourselves with the cart in front of the horse, so to speak, and not knowing what to do once we have some answers. And that brings me to the second question that I wanted to address very briefly, and that is the question on what social science is needed in this context. And I think this is absolutely essential because, in the context of climate change, things will change, right? Things will change. So we need to understand who is being affected by the change, how to compensate those that are being affected, what are the alternatives? And all that is effectively boils down to trade-offs. Those trade-offs have to be driven politically by the political objectives of the countries, but the trade-offs need to be economic and socially computed. And one needs social science to understand that, to understand the impacts of particular changes and the impact of the alternatives. And without that, fighting climate change is just playing in the dark. You don't actually really know what you need to do. So social science is crucial as long as natural science, even though I'm a natural scientist, so I have a particular affinity, but social science is essential. Thank you.
Yeah, thanks for your remark on this. So I'm a social scientist, and I like when people are asking, so what role shall social science take in this? So I think we covered a pretty nice set of ideas on this. Laura, I would like to ask you, from what you've heard so far, do you have any final comments before we are going then to our wrap up?
Thank you for the very interesting discussion. I think there's one thing I'd like to address that relates to the 100% sustainably managed oceans, which I think is a vision that we share. And as part of that, setting aside a third of those areas and ecosystems for protection is part of that 100%, including as recommended by the scientific advice for the high-level ocean panel for sustainable ocean economy. And I think the question on social sciences is a very interesting one, and it makes me think of the conversations I've had with my colleagues in Senegal recently, where the kind of small-scale fisheries and the female fish processors are increasingly finding it difficult to make income due to the industrial fishing that is overfishing that is happening offshore the West African coast. And I think like more understanding into in where the fish flows, how they move around the world, and who is benefiting, and what a just transition to globally sustainable fisheries would look like from the perspective of, for example, the coastal communities that are very dependent on fish for subsistence and income, to reach the vision of sustainable seafood worldwide. Thank you.
Yeah, thanks for your comment. And I think everybody stressed this importance of interdisciplinarity and the research on the one hand, and then when we're looking at the forecasting models, taking into account this whole value chain. So from observations to the data management to the information products that then hopefully will be addressing the needs of the society or the users of these products in the right way. Yeah, so thanks to all for this nice conversation, and I'm handing over to Elias, who's going further on in the agenda.
Thank you very much, Sandra, for moderating the Q&A discussion. Well, following such a lively discussion, I couldn't be more than glad to proceed with welcoming Noel Kinleyside and also MEP Pierre Karleskind to address the closing remarks. I think that having both speakers following up is a great personification of the science policy nexus. So to begin with, Mr. Noel Kinleyside is a professor at the University of Bergen and Berker Center for Climate Research. He's also a climate researcher with more than 20 years of experience, focusing on climate prediction and its implications. Moreover, he has also coordinated two major EU projects, Preface and Triatlas, that focus on the prediction of climate and impacts on marine ecosystems in the tropical and South Atlantic. So, Noel, looking forward to hearing from you.
Can you hear me okay?
Yes, very well.
Okay, very good. So thank you. So dear honourable members of the European Parliament, dear panellists, dear members of the audience, I would like to thank you for your participation in this briefing arranged by these three EU projects, Blue Action, Triatlas and Mission Atlantic, and kindly hosted by the MEP Pierre Karleskind and opened by the MEP Isabel Cavallais. So I'm very happy to have this opportunity to make these few closing remarks. And I'd like to begin with the bit of good news that we've actually already mentioned a few times today. It's the agreement signed between 14 countries that have pledged to end overfishing. Two of these countries include two from Europe, Norway and Portugal. And I'd like to just echo the statements from Anna Solberg, the Norwegian Prime Minister. So humanity's well-being is deeply intertwined with the health of the oceans. It sustains us, stabilizes the climate, and leads to greater prosperity. For too long, we have perceived a false choice between ocean protection and production. So that's something that has been going on through this session very nicely. No longer we understand the opportunities of actions and the risks of inactions, and we know the solutions. Building a sustainable ocean economy is one of the greatest opportunities for our time. So I think it's wonderful to hear a person in power making these statements. So clearly this agreement is a beacon of hope. It is also important to stress that the sustainability does not necessarily conflict with productivity, another thing that has been going on through this session today. And we see, for example, research shows that if human activities in the oceans were sustainably managed, they could provide 6 times more food than today. So today we have had a very illuminating session. The speakers presented a vision of an understanding and a digital tools or digital earths. These tools can provide us a picture of how bad the future will look or good. Importantly, the predictions described today deal with the near term and with ecosystems. So that is with what will happen over the next seasons to years and into the future. And they deal with how climate change will influence the marine ecosystem in this time frame. So together with other human pressures. The presentations have introduced the importance of ecosystem-based management, the need for integrated and sustained observations, the need to scale up the pilot fish forecasts that were introduced by Mark to operationalize them, and the use of these fish forecasts to help protect ecosystems in our global oceans. The fish forecasts are solutions that can be showcased as innovative services for the achievement of the European Green Deal and the European Climate Pact. So it was also nice to see the remarks from the panelists in response to the vision presented in this briefing. It was great to see, the positive remarks from the panelists, including the members of the European Parliament, the program managers from the European Commission, the FAO and Europesh. I heard many times the importance of science-based advice for policy management, the potential of scaled-up fish forecasts as a tool for managers. Echoed many times was the need for considering sustainability and exploitation together, and that a healthy environment and ecosystem is a basis for our economies. Also that the European Union is an important funder of basic research in this area. So I'd like to conclude by making 3 points more related to my own background and the research that I've been doing. Firstly, I'd like to say that scaling up climate-based predictions of marine ecosystems requires the construction of integrated numerical systems. So it really requires bringing together numerical climate predictions and marine ecosystems. Bringing these fields together will allow more comprehensive predictions of the ecosystem changes from weeks to years into the future. However, this is a hugely challenging task. There's a tremendous range of timescales, spatial scales, and complex ecosystem interactions that all need to be taken into account. Second, while we've heard, climate predictions are making great advances, there's still much work that is required to realize the full potential of climate predictions. So something that hasn't been discussed in this session is model systematic error. So the North Atlantic is one of the regions of the globe where current multi-year predictions show great accuracy and can benefit ecosystem predictions. However, recent research shows that we can even predict, even with greater accuracy, up to 10 years in advance if model errors are reduced further. So concluding on those 2 points, new tools from artificial intelligence, together with comprehensive ocean observations and large supercomputers to model systems, are needed to achieve these goals, to build integrated climate ecosystem predictions and to reduce model errors. And the third point I just wanted to make is the Atlantic needs to be considered from pole to pole. The ocean currents like the Gulf Stream bring heat from the south to the north. The atmospheric circulation brings heat and moisture from the tropics to high latitudes and from the oceans to the continents. Thus, we cannot understand how climate and marine ecosystems will change in our region without considering the entire Atlantic and taking a global perspective. Furthermore, there's an interconnect in our social and economic systems. The European Union recognizes the importance of considering the Atlantic in its entirety through the Belém and Galway statements and through funding projects like the Blue Action Mission Atlantic and Triatlas. For example, the All Atlantic Ocean Research Forum initiated by the European Union. This forum is meeting right at this very moment and discussing the important issues. With this, I'd like to thank you for your participation in this policy briefing, which I think has been a great success. And I would like to pass the final word to the Honourable Mr. Pierre Karleskind, who kindly hosted this event. Thank you.
Thank you very much, Noel, for your intervention and co-addressing the closing remarks. It's with great pleasure to invite Mr. Karleskind to take the floor. Mr. Karleskind is a member of the European Parliament for the Renew Europe group, and quite remarkably is also the chair of PESH committee, but also holding a PhD in oceanography. So we're very much looking forward to your intervention now. Thank you very much.
Thank you, everyone. And indeed, I'm holding a PhD in oceanography and especially in ocean modeling. So this is why I'm so happy to conclude this special webinar on topics which is so familiar and in which I've been professionally involved. So I would like to thank first all the participants for their contribution and for this discussion on these really interesting topics. We must just see, and you have highlighted so well, that the ocean is continuously is always evolving, and Mr. Schmidt clearly showed us this in his presentation. The climate change speeds up this process, and we need fish forecasting. We need scientific observation. We need them because they are essential to predict the distribution and abundance of fish in the years to come. And Dr. Payne showed us in this presentation with the example of the forecast of the distribution of the blue whiting. We already have important observation records and data about the Atlantic Ocean, and we need to carry on collecting them. We had a presentation this morning, today, in the PESH committee of the 2019 report concerning the data collection framework. We have data, but the first marine ecological forecast and climate services emerged mostly during the last decades. These tools are really important in order to get a better understanding of our ocean. Mrs. De Jong showed us highlighting that long-term observation are critical for understanding and having accurate prediction on ocean and ecosystem change. This is crucial for the sustainability of fishing. But these tools are still not used as they should be. Not enough use. So far, the data collected doesn't seem to have a significant impact on fisheries management and sustainability, depending maybe on the level of which you're considering. But the main obstacles of our lack of awareness around these technologies, a lack of trust to such forecasts, and a cooperation between scientists and end user, which is not yet optimal. Therefore, I think it is really necessary to improve it and recognize their importance. What can we do as policymakers, our policy influencers? And I'm really glad to welcome this webinar with my colleague Grace O'Sullivan and Isabel Carvalhais. It is to raise awareness on these technologies and on research, and to ensure proper fundings in order to develop at a larger scale. I welcome with great pleasure the proposition of the mission Starfish 2030 of Pascal Lamy, which emphasizes precisely on this question of knowledge and of modeling. He's even proposing something which is quite crazy. It's the digital ocean twin. Maybe this is a first step to raise awareness of everyone on that. But because with these types of technology, we would be able to have a larger perspective, which would allow which will allow us to make more efficient policy. I must tell you and confess that so far we've been considering the sustainability of fishing through MSY, maximum sustainable yield, which is the result of a quite really simple ecosystem model. A stock model, not a real ecosystem model. We now have the tools. We have tools to have a real ecosystemic approach of policies, such as the common fishery policy. We must use them. I think this is the challenge of the next years. This exchange will be taken forward directly by myself, my colleague Isabel Carvalhais and Grace O'Sullivan, and all our colleagues of the Committee on Fishery of the Parliament. I look forward to hearing you again on this topic, and in order to make sure we take the right decision to act towards a more sustainable and a modern fishery policy. Once more, thank you to all the panelists, thank you to all the people that were with us this afternoon, and thank you once more to the staff of the EBCD intergroup. Thank you.
Thank you very much, Mr. Karleskind, for your closing remarks. On behalf of the European Parliament Intergroup Secretariat, I would also like to thank MEPs Ms. Carvalhais as well as Ms. Grace O'Sullivan. Big thanks also to all of our speakers and participants regarding today's event. It's been a great pleasure having this webinar with you today. So since that was our last one for 2020, we're all very much looking forward for the ones to follow in 2021. Until then, all the best and stay safe. Thank you very much. Bye-bye.